Hello everyone. So I'm going to do another one of these Markdown / PrairieLearn question creation videos. Today what we're going to do is we're going to try to do a question that requires symbolic input. So they have to actually enter an equation with symbols as their solution. The question we're going to try is from volume 2 of the OpenStax textbook. It's chapter 12 again, and it's question 18, and I've got that displayed here. And so what the question has is these kind of semicircular loops of current. And the question is simply, what is the magnetic field at the point P? And so we're going to ask them to try to find the magnitude of this magnetic field and enter in an expression, and that expression will depend on the two radii A and B as well as the current I. The other thing that this will force us to do is to learn how to include an image in our question. And so those are the two goals, is to figure out how to write a symbolic input question and to include an image in our question. The first thing we'll do is we'll get this image, and the way I'm going to do it is I'm going to go to the solution manual and I'm going to click on the image. It's reproduced there, and I'm going to say picture as, and then let's see, I'm going to put this in a directory here. I'm going to use this one, problem 12_18A, and I'm going to call that image OpenStax University Physics Volume 2 problem 12_18, and the format you want is PNG. And so the first thing I'll do is save that. I'm not going to bother making a video where I solve this problem, but the solution is here. It's mu naught times I over 4 times 1 over A minus 1 over B. And so that's what we'll use as our solution. Okay, and so here's a browser. Again, we're not going to create this question from scratch. What we're going to do is we're going to go find ourselves a template. And so I'm just going to sign in. And we'll go to the instructor physics bank, and so here's some templates, and there's a couple symbolic input questions, and so I don't know, we'll just pick the first one here, and let's look at this, and we'll just copy everything that's in here. And I've got a notepad, so I'll just paste that all into Notepad, and I'm going to save this as in the same place where we saved that image. So when we navigate to this folder, we should find our image. So if I was to look at all the files, our image is in there. I'll call the question the same thing, but I'll make it a Markdown file. Okay, and then so Notepad does some highlighting for us, which is nice. And so what we're going to try to do is we're going to try to edit this question. While we're at it, I'm going to go back into these templates, and I think there's one of them that will show us how to put in an image, and I think it's this question 10 integer input. And so we'll look at this one, and let's see, is this the one I want? It is not the one that I want. Okay, so I'm going to go back and I'm going to try to find the right one. Well, let's just try this multi-part. Okay, so here this multi-part example has a test image 1 and test 2, and so that's the one we want. And so let's look in here. And so you see here in this assets field, they label the file names of the images they're going to use, and then they include the image here. So why don't we just copy this and we'll put that into another tab in Notepad so that when we need it, we can go ahead and use it. All right, and so let's just start modifying this template. So I'm going to call it OpenStax University Physics Volume 2 Problem 1218. The topic is, so what are we supposed to do? We're supposed to go and look at, in the instructor, in open resources, you're supposed to look at learning outcomes, and let's look at this master list and find the magnetic field ones. Ours is about calculating magnetic fields from a current, so we'll see what is relevant in here. Whoops, sorry. And so we'll go back into this. So we're looking for these magnetic field ones. Here's electrostatic magnetism. Okay, so magnetism, magnetic fields. We're not doing magnetic field lines. We're not doing motion of a charge. Field produced by a current. We're sort of doing that, but we're not doing Ampere's law. So that doesn't work. We're not doing magnetic force. And so I think what we need to do is we need to pick one of these early ones. And so define the magnetic field based on moving charge, experience of force, I don't know. Solve for the electric field by changing it, no. Explain energy. Yeah, I don't love any of these ones. Let's see. 19. So I think we're going to use this first one here. Let me copy that and define the magnetic field based on a moving charge experiencing force. Okay, we'll go with that. It seems to be the best option. And so the topic is magnetism, I think. Let's just go check that one more time. Yeah, magnetism. And okay, so that's fine. And so for the author, put my name. And for the source, we want that OpenStax attribution. Oh, no, sorry. For the source, it's going to be Volume 2, Chapter 12, Question 18. Template we can leave here is where, for attribution, we want to put in the OpenStax. So OpenStax Physics Volume 2, I think, is the syntax. And so learning outcomes, that's what we just looked up. And I think I should just be able to paste that. And there it is. Okay, difficulty we'll leave alone. Randomization we'll leave alone. We'll leave that alone. Tags. Okay, so for the tags, I like to put OpenStax University. So OpenStax University Physics. Whoops. And Volume 2. Maybe Chapter 12. Problem 18. What are we doing? We're calculating a magnetic field. And the source of the magnetic field is a current, maybe. When you do solve this problem, it's not an Ampere's law problem, it's a Biot-Savart law problem. And maybe what I'll do is I'll just say that this is a symbolic type problem. Okay, so for assets, Assets is the image we're going to use, and we called it OpenStax University Physics Volume 2, Problem 1218, and it's a PNG file. Okay, for all these inputs, we'll leave those alone. We'll leave this nested dictionary thing alone. This, I don't really know what this does, and I don't think we need it, so I'm just going to go ahead and get rid of it. And so here, we're going to enter in the symbols that are going to be needed in our solution. And the symbols that are going to be needed are the two radii, A and B. We're going to need the current I, and we're going to need mu naught, the permeability of free space. And so what I've been doing to get Greek symbols is I've been searching for Unicode Greek letters. And so I think if we click on one of these first links and we just find mu in here, there it is, we can copy this and then we can paste it back into our Markdown file, and I'm going to put a 0 after that, so it's a mu naught. And then we just want to repeat these symbols inside the brackets of this expression here. And so these are the variables we're going to use, except we don't want the commas inside here. Okay, and now we're just going to enter in the solution. So it's B is equal to, so it's mu naught. So let's see if we can just copy mu naught times the current divided by 4. And then it's a difference between the inverses of the radii. A is the inner radius and B is the outer radius. So 1 over A is bigger than 1 over B, so this turns out to be a positive number when they take the difference. Okay, and so here, this is just going to pass the answers to the PrairieLearn system, and so we're solving for B, and so we'll put our answer as B. And then all of this other stuff, we can just leave it alone. And so there's actually an error in this template. This part where they're passing the label option should really be underneath this PL customizations heading. It won't work if you don't put it there. And so I'm going to move that. So the type of question is going to be a symbolic input question. The label is what students will see. It'll say B equals, and then they enter their stuff. So we put in our label there, and then the variables that are going to be used are the same as what we defined up here. So I'll just copy them all. Okay, and that's it. So we won't change anything else here. So now what we're going to do is we're going to edit the question. And so the question was, what is the magnetic field at P due to the current I in the wire shown? So what I'm going to do is I'm going to say, what is I'm going to ask only for the magnitude of the magnetic field. Of course, the magnetic field is a vector, so it has a magnitude and a direction. So what I intend to do is first focus right now just on the symbolic part, but then in the next video, we'll come back and we'll edit this question so that we ask students to also specify a direction. Okay, but for now, what is the magnitude of the magnetic field at point P due to the current I in the loop of wire shown. Okay. In this template, they've constructed this table showing students what variables need to be used. I'm just going to go ahead and get rid of that. And now what we're going to do is we want to include the image that we need to use. And so the syntax for including an image here is this img src. This is HTML syntax. So we'll just copy that, and we're going to put in OpenStax University Physics, Volume 2, Problem 1218.png. You can scale your image, change its size by specifying a width. So I'm going to use 300 in this case. The other thing that we're being asked to do that we should try to do is specify this alt tag. So what this is used to do is, if for whatever reason the image doesn't display, it'll show some text saying what the image was supposed to be. Or if someone is vision impaired and they're using a screen reader, then the screen reader will read whatever you write in this alt tag. And so, I don't know how detailed we should try to be, but what we might do is we might say like a semi-circular loop of current. Okay, so that doesn't give enough information to see the full geometry of the problem, but it gives some idea of what the image is. Now, when the students go to enter their answer, they're going to have to enter in this Greek symbol mu naught. And the way I've been handling this is I've been putting a line that says, you may copy the Greek symbol, and then let me just copy mu naught again, mu naught into your symbolic expression. I'll show you what that looks like when we get there. All right, and then I'm not sure what this is in this answer section, but I don't think we need it. So see you later. And we're not going to have any comments in the submission panel or the answer panel. So we'll get rid of all of that. And, with any luck, I think that's it. So let's have a go at converting this into PrairieLearn. So I've got another browser open here, and I'll just quickly do this conversion to PrairieLearn. And now I think we called the folder A, right? And let me just double check that. Yep. Okay, and so let's see what happened. So it says it did it. Let's go have a look. So it created these 4 files, and I'm gonna have to move those over into my repository. So volume 2, chapter 12. So I've already got problem 18 in here. I'm just going to get rid of everything that's in there, and I'll paste in our new stuff. Okay, and then I'm running PrairieLearn locally here, so we can just see what it looks like. So let's load this up. Let's look at the questions. And here's question 18. Okay, so here we go. What is the magnitude of the magnetic field at point P due to current I in the loop of wire shown? Here's our image showed up. You may copy the Greek symbol and a bunch of crap into your symbolic expression. And so what's happening is somewhere in the conversion from a Markdown file to PrairieLearn question file, the symbol mu is getting screwed up. And so maybe that's going to get fixed in the future. But for now, what we could do is we can go into, so we're in preview tab right now. We can go into files and question HTML. And now we're just looking at it. And so it's here where our mu naught has been corrupted. So we can go and edit this. And if we just get rid of all of that stuff, do I still have, so I think I gotta go back to, let's just see if we can copy the mu symbol. And let's see if we can paste that in there and then save and sync. And now let's go back to questions. And so there it is. So there's our mu naught. Now, let me just enter a wrong answer. Let's say I entered G. And so it said that this question was not graded because I had an invalid entry. And so if I ask why is that invalid, well, it says I entered a G, but G is not allowed. What I'm allowed to use are A, B, I, mu naught, pi, E, these trig functions, and so on. So it says I entered something that's invalid. So if I just enter an A, which is wrong, but it's an acceptable variable, then it gets marked as being wrong. And so now I can enter, let's see if I can remember it. So it's mu naught times I. So I'm going to copy the mu naught here. And times I, divide by 4. And then that was times by 1 over A minus 1 over B. And let's grade that. Okay, so that's good. One nice thing about this is that it will also mark equivalent expressions that aren't exactly like this as correct. So for example, 1 over A minus 1 over B, is it equivalent to, I think it's equivalent to B minus A all divided by A times B. I better put that in brackets. And so there's an equivalent expression. It's not what we entered in the server file in that part of the Markdown code, but it's marked as an equivalently correct answer. Okay, good. So that's that. I'm going to stop this video here. We're going to come back to this and I think edit this question so that we can add some direction information. All right, so thank you very much.